Hi, I'm Naoko Okubo from Japan Aerospace Exploration Agency. This work is done by my colleague, Kenji, Yasushi, Masa, and also our partner, Dr. Toshiyuki Amagasa from University of Tsukuba. Today, we would like to share our experience about supporting the review to identify the lack or insufficient requirement in space system. And as a method, we use machine learning to support it. So let's get started. So first of all, we think the space system is sort of autonomous system. And our strong motivation is we want to prevent the mishap or failure which happen in those kind of system. As an example, I'd like to share about the Mars polar lander crash. This lander crashed in Mars surface, and we don't know the exact what happened because it's all happened in the Mars, but it is said that the crash most likely happened because it failed to recognize the correct situation of the lander. I don't go detail of it, so if you're interested in, please see the report in bottom part of the chart. So we want to identify such failure before the operation, which means during the development phase. And to find them, we think that formal verification techniques is one of the strong solutions to find it. However, we also think that formal verification techniques deeply depends on the specification or requirements, because the formal verification often proves the correctness of the design which based on the specification or requirements. So when we look back the Mars polar lander, its requirements in the failure situation were lacking. It was missing. So it can easily imagine that it will be really difficult to conduct formal verification techniques and success when the situation was when the requirement is missing. So we think that preparing sufficient requirements is a key factor of success of the autonomous systems. So to prepare the sufficient requirements, our organization, JAXA, have several review boards to discuss about project issue, including insufficient requirements and design stuff. The figure in upper part is representing the review board, the big review board in our organization. And we also have a small one and a lot of small ones too. So when we want to identify the insufficient requirement, we think that it's quite difficult to identify them, but by just looking at the requirements, we know it will be low cost consumption if we found in a really early phase, but it's still it's really difficult. However, when the requirements turn to the design, behavior of the system or software get more clear, and insufficient part can be found more easily. So our presentation is talking about the design document. So I'd like to explain about issue of review boards. The figure in this middle part is representing the review procedure. Reviewer, which is here, and he or she is often well-experienced engineer, use viewpoint to the review which came from their experience, and their experience is mainly about the failure experience. and they connect viewpoint and they extract viewpoint from their experience and connect information from input documents, which mean the review target, and output the suggestion about the potential failure, which mean the insufficient the possibility requirement. So the issue of this review board is we cannot assign well-experienced engineers to all review opportunities in our organization because, as I mentioned before, there are a lot of review opportunity, and we can assign all of the opportunity. And well-experienced engineers is really less number. And also, past experience can be interpreted in several ways, and they interpret their past experience applying to the input targets, so it's really hard to share with the other. So this is the issue of the review boards. So this is the idea to overcome the issue. We want to support the intermediate engineer which participate into review board. But their experience is lower than well-experienced engineer. So we would like to search meaningful anomaly reports instead of well-experienced engineer knowledge. This is, excuse me. So the idea is representing is the bottom figure. To search the meaningful anomaly report toward the review target, we would like to apply the machine learning. But to determine meaningful or not, we train the machine learning model with data of human judgment with positive relation and negative relation between the review target and anomaly report. And the determination is done by holistically instead of extracting the exact viewpoint for anomaly reports. We tried it, but it was so difficult. So this is the thing what we want to do. So through this approach, we have two questions to share today. First one is, what attribute can determine the positive or negative relation between review target and anomaly report? Maybe it will be similarity of the keyword, or similarity of the sentence, or maybe any other feature that we don't know yet. The second question is, does our approach support the design review, which means the real design review, and contributes to identifying sufficient requirements? So we would like to answer to these questions. Before that, we would like to introduce about our feature, our data's feature. Excuse me. So this is the feature of our data. First one is design document, which is review target. The feature of this data is sometimes it's written in really high abstraction, especially in early development phase. In opposite, we have anomaly reports, and this anomaly report is written really concretely. It's representing factual information like what happened, its cause, and what you did to prevent them. So, and also it's collected across product in our organization, like the anomaly from launcher system, Earth or a satellite system, and some ground system as well. And also development companies are different, and also the writer of the anomaly report is different. The quantity of anomaly report is 41,000 items since 1970s. So we want to search appropriate anomaly report from this quantity. And yes, we need to say that it's all written in Japanese. So this is the example of design document and anomaly report. I don't read through it, so if you feel interested about it, please stop the video. So to figure out the feature of data, we conduct several preliminary experiments, and we would like to share about the experiment about keyword matching. I won't go. We would like to just go through the overview of the results. The precision rate, which means the that we searched the meaningful anomaly report or not, was about 8%. This means it's really awful. And we found two problems. One is homograph problem. Example, the wheel is using two different meanings in our organization. One is the wheel, it's tire, which is part of the ground vehicles. And another one is a component of reaction wheel, which is used to control attitude of satellite. Those wheels are completely different meaning, but they treat it as same thing, so the precision rate goes down. And also, we have spelling variation problem, which is opposite of the homograph problems. For example, STT and Star Tracker is completely same thing, but it's treated as different things, so the precision rate goes down as well. So we need to tackle with those kind of problem to support the review. So we would like to introduce our proposed method and its evaluation result. This is corresponding to question number 1. What will be the feature to explain the relation between design documents and anomaly reports? This is the proposed method. We observed the homograph and spelling variation problem though. We don't want to make dictionary to overcome those problems or taking approach related to ontology because it's too consuming. So we decided to apply neural network, and we select convolutional neural network this time. The convolutional neural network model is represented in the bottom part of the figure, the bottom part of the page. We input the design document words and also the anomaly report words and go through the convolutional network. So as the output, if this two combination is meaningful or not can be observed. So we train this convolutional neural network using supervised signal, which I mentioned before, like human judgment of positive relation or negative relation of two combination. And we also select the comparison method to the proposed method. And we select the sham network, which use also the neural network. A motivation to apply sham network is the assumption that the two document relation is coming for the similarity. This is said in many of related work. The feature of the network is the network extractive. The network is upper part network and bottom part network is completely same thing. So that means the design document and anomaly report will be if the design document and anomaly report is similar, the output from the fully connected layer will be quite similar. And if the precision rate from this network will be high, the two the relation can be explained by the similarity. So we select this network as comparison method. Also, we prepare dataset to evaluate them. We collect data design document for attitude control subsystem from satellite systems. And we also collect anomaly reports, which I mentioned before. And also we prepare the supervised signal, 5,000 signal, which is 882 positive samples and 4,118 negative samples. So we train the model by using the supervised signals. And this is the comparison result of proposed method and sham network. And as you can see in the table, the upper part is the result from sham network and the bottom part is our proposed method. And as you can see from it, the proposed method can predict well compared to sham network. So the results suggest that not only the word or sentence similarity, but different attributes are necessary to solve our problem. This was a really important finding for us because most of related work having good precision rate with similarity. So it's representing the uniqueness of our data. So after we train our proposed model, we conduct a trial towards simulant design review. This is corresponding to question number 2. Does our approach support the design review and contributes to identifying insufficient requirements? So, as an experiment condition, we select one satellite system and single reviewer which has high expertise and that satellite system was already complete the design review. The reviewer extracted 10% of the text from the design document, which means the review target, and that was the one determined to hold careful review again. And also the top 3 search results through proposed model were provided to the reviewer. After provided, the reviewer judged if the anomaly reports were meaningful or not. As a result, only 5 out of 30 anomaly reports contribute to generate the review comments, which means the precision rate is around 16%. Also, none of the insufficient requirements were found by this trial. We would like to wrap up the presentation. We proposed the positive-negative relation estimation model between design document and anomaly report, which contribute to figure out the insufficient requirement for a space system. And we think the space system is an autonomous system. And we found that not only the word or sentence similarity, but different attributes are necessary to solve a problem, and this was a really important finding for us. As a future work, we would like to investigate the attribute which contribute to our task, because our method was using neural network. It's really hard to identify the attribute which contribute to the results. So we would like to investigate more further. Also, we like to we would like to conduct careful analysis about the low precision rate at the trial. So thank you for watching. See you.